Hello students, in this session we shall study about the mean deviation for continuous frequency distribution. Let us see what is a continuous frequency distribution. A continuous frequency distribution is a series in which the data are classified into different class intervals without gaps along with their respective frequencies. For example, marks obtained by 100 students are presented in a continuous frequency distribution as follows: marks obtained from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60. Here corresponding number of students are 12, 18, 27, 20, 17 and 6. That means 12 students have got marks between 0 to 10, 18 students have secured marks between 10 to 20 and 27 have secured marks between 20 to 30 and so on. Now let us learn how to calculate the mean deviation about mean. While calculating mean of a continuous frequency distribution, we had made the assumption that the frequency in each class is centered at its midpoint. Here also we write the midpoint of each given class and proceed further as for a discrete frequency distribution to find the mean deviation. Let us take up an example. Find out the mean deviation about the mean for the following data. Marks obtained and number of students are the two columns. Marks obtained are ranging between 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80. Number of students correspondingly are 2, 3, 8, 14, 8, 3 and 2. Now, we make the following table. First column shows the marks obtained, second shows number of students, that is frequencies, third column is midpoints, that is xi, fourth column is for the product of fi and xi, fifth column is for absolute value of xi minus x bar, and sixth column is for the product of fi and absolute values of xi minus x bar. Look here how we do it. We have product of fi and xi in the fourth column. 2 into 15 is 30, 3 into 25 is 75, 8 into 35 is 280 and so on. We add and calculate summation of fi xi as 1800. Similarly, we have added the frequencies to find here that it is 40. Now we calculate xi minus x bar, that is 30, 20, 10, 0, 10, 20 and 30. Then we find the product of fi and absolute value of xi minus x bar, that is 2 into 30 gives us 60, 3 into 20 gives us 60, 8 into 10 gives us 80, 14 into 0 is equal to 0, 8 into 10 is equal to 80, 3 into 20 is 60 and 2 into 30 is 60. On adding this, we find that the product is 400. Now let us look at the computation. Here n is equal to summation I ranging from 1 to 7 fi is equal to 40, summation I ranging from 1 to 7 fi xi is equal to 1800, summation I ranging from 1 to 7 fi into product of absolute values of xi minus x bar is equal to 400. Therefore, x bar is equal to 1 upon n into summation I ranging from 1 to 7 into fi xi, that is equal to 1800 upon 40, that is equal to 45, and mean deviation about mean, that is x bar, is equal to 1 upon n into summation I ranging from 1 to 7 fi into absolute value of xi minus x bar, that is equal to 1 upon 40 into 400, that is equal to 10. Therefore, the mean deviation is 10 here. Now, let us learn the shortcut method for calculating mean deviation about mean. We can avoid the tedious calculations of computing x bar by following step deviation method. Recall that in this method we take an assumed mean which is in the middle or just close to it in the data. Then deviations of the observations or midpoints of classes are taken from the assumed mean. This is nothing but the shifting of the origin from 0 to the assumed mean on the number line as shown in the figure. You can see in the figure the values 0, 10, 20, 30 ranging till 120. This is before the deviations, and when we assume 60 as the mean, the corresponding values are 10, 20, 30, 40, 50 after deviation, and similarly here minus 10, minus 20, minus 30, minus 40, minus 50 and minus 60 after the deviation. If there is a common factor of all the deviations, we divide them by this common factor to further simplify the deviations. These are known as step deviations. The process of taking step deviations is the change of scale on number line as is shown in the figure. We can see here the values 0, 10, 20, 30, 40 till 120, and these are the deviations from assumed mean minus 60, minus 50, minus 40, minus 30, minus 20, minus 10, 0, 10, 20, 30, 40, 50. After step deviation, because 10 is a common factor, we have divided by 10 and the values have changed from minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5 and 6. The deviations and step deviations reduce the size of the observations so that the computations like multiplication, etc. become simpler. Let the new variable be denoted by di, that is equal to xi minus a upon h, where a is the assumed mean and h is the common factor. Then the mean x bar by step deviation is given by x bar is equal to a plus summation I ranging from 1 to n fi di upon n into h. Let us take the data of previous example to find the mean deviation by using step deviation method. Take assume mean a is equal to 45, that is somewhere between 10 and 80, and h as 10. We make these columns. First is for marks obtained, second for number of students, that is fi, third is for midpoint xi, and fourth column is for di, that is xi minus 45 upon 10. Next column is for fi di, that is product of frequencies and deviations, and next column is for absolute value of xi minus x bar, and last one shows us the product of fi and absolute value of xi minus x bar. Now, we take the midpoints of 10 and 20 class interval, we get here 15, 20 to 30, we get here 25, similarly for all the classes, and look at the deviation xi minus 45 upon 10, that is we take 15 minus 45 upon 10, that gives us minus 3. Similarly, 25 minus 45 upon 10, that gives us minus 2. 35 minus 45 by 10, that gives us minus 1, 45 minus 45 by 10 gives us 0, and so on. Now, we find out the product of fi and di. 2 into minus 3 gives us minus 6, 3 into minus 2 gives us minus 6, 8 into minus 1 gives minus 8, 14 into 0 gives us 0, 8 into 1 gives us 8, 3 into 2 gives us 6 and 2 into 3 gives us 6, and we can find here the sum of these observations is 0. Now we find out the absolute value of xi minus x bar. They are 30, 20, 10, 0, 10, 20, 30 respectively. Now we find the product of fi and absolute value of xi minus x bar. They come out to be 2 into 30, that is 60. Similarly, 3 into 20 is 60, 8 into 10 is 80 and so on. And we also find the sum here as 400. Therefore, x bar is equal to a plus summation I ranging from 1 to 7 fi di upon n into h is equal to 45 plus 0 upon 40 into 10. That means x bar is equal to 45, and mean deviation about the mean is equal to 1 upon n into summation I ranging from 1 to 7 fi into absolute value of xi minus x bar. So, mean deviation is equal to 400 upon 40, that is equal to 10. Note that the step deviation method is applied to compute x bar, rest of the procedure is the same. So, students, we learned how to calculate mean deviation for the group data in the case of continuous frequency distribution. We shall continue in the next session to find out mean deviation about median. Thank you.